Good afternoon, students. Am I visible and audible to all of you? Seeing you all after a week. Students, good afternoon. Am I visible and audible to you guys? Jain Ramnagar students, am I visible? Can you able to hear my voice? Hello. Hello, students. Am I visible? Yes. Okay, good. So in the last class, we have discussed the redox reactions lesson, right? So in this class, we are going to see the crash course kind of part of general organic chemistry, that is GOC. Okay. So here in this lesson, we are going to discuss the introduction to organic chemistry and representation of organic compounds, classification of organic compounds, nomenclature part, both common name and repack name we will discuss, and isomerism, reagents in organic chemistry, reaction intermediates, and all the electronic displacement effects. 4 effects we have, right? So all those 4 effects we will discuss, and at last we will discuss the aromaticity. Okay, so all these things we have discussed in detail during the class time. Now we are going to see the gist of all these things here in this session. Okay, we will try to cover as much as topics we can for today, and if we cannot complete, we will continue it in the tomorrow's class. Okay, so let's start with the introduction to organic chemistry. So organic chemistry mainly deals with carbon, right? So why carbon? There are 2 reasons. One is tetravalency. One more reason is there. Can you tell me that reason? What is the name of the second reason? Do you guys remember? Organic chemistry is has arisen mainly because of carbon, and it is because of carbon due to 2 reasons. The first reason is the ability of carbon atom to form 4 bond, and we call that as tetravalency. And we have one more reason. What is that reason? Can JNV Ramnagar students try the answer for this question? One is tetravalency, the other one is tetravalency, and because the ground state electronic configuration of carbon is 1s2 2s2 2p2. So there are 4 electrons here you can see in the valence shell of carbon, and that's why carbon forms 4 bonds, right? So this is the first reason. What is the second reason? Do you guys remember or not? If you remember, just give me the answer. If you don't remember, just type that you don't remember in the chat box. I will go continue with the class. Shall I? Shall I tell? Shall I give the second reason, or you guys want to give a try? Very good. Very good, students. It is because of catenation. Very good. Great. So what is catenation? Ability of carbon atom to form long chains or rings is known as catenation. So this is the second reason. So because of these 2 reasons only, the separate branch of chemistry called organic chemistry has arisen. Okay, because of carbon. So coming to the next point, so you might have seen this tabular column, right? So we have a hydrocarbon. We have 3 hydrocarbon. One is an alkane. Okay, and the hybridization of the carbon atoms in alkane is sp3, and in all the alkenes, the carbon-carbon bond length will be 1.54 angstrom. Okay, and that shape will be tetrahedral. Okay, this particular angle is very important. 109 degree, 28 minutes. This is very important. Tetrahedral bond angle. Coming to alkene, the hybridization will be sp2, 1.34 angstrom will be the bond length, and the shape is trigonal planar with 120 degree. And coming to alkyne, the hybridization is sp, Bond length is 1.20, bond angle is 180 with linear shape. Okay, methane was taken as an example, and for alkene, ethene, and for alkyne, ethine. Okay, so if you see any compound with carbon-carbon single bond, just go for the hybridization as sp3. Double bond sp2, triple bond sp. Bond length decreases from alkane to alkyne. Okay, bond length decreases from alkane to alkyne. So this is one of the very important point, and all the angles and all the shapes you should know. Okay, so this tabular column, as I've already shown you in the class, it is important. Then coming to the representation of organic compound, coming to the representation, so a structural formula can be represented using uh, three ways. One is complete structural formula, the second is condensed structural formula, the third is bond length structural formula. So let me take an example for you and then explain all these three. Okay. So I'll take butane. I'll take butane. So what is the formula for butane? Do any of you know the formula for butane? How many carbon atoms will be there in butane? It is 4 carbon, C4 and H10. So this is the formula for butane. Now, if I have to draw the complete structure, I have to show all the carbon-carbon single bond as well as carbon-carbon, carbon-hydrogen single bond. So 1, 2, 3, 4, and each carbon has to have 4 bond. So it is CH3 and here CH2. Okay, and here CH2 and here we have CH3. So this is the complete structure which shows all the carbon-carbon single bond and carbon-hydrogen single bond. Now, if I have to condense this particular structure, I can write like this: CH3, CH2, CH2, and CH3. Okay. Now here I have shown only the carbon-carbon single bond and not the carbon-hydrogen single bond. I can further condense this by removing all the carbon-carbon single bond also. Okay. If I remove that, what I will get? CH3, CH2, CH2, and CH3. So this is the further condensed form. Still, I can condense this. How can I do that? So CH3, CH2 two times. Okay, we have two CH2, right? So CH2 two times and CH3. So this is the further condensed form of butane. All these three are called as the condensed structural formula for butane. Okay, any doubt from this? Shall we go to the bond length structural formula? Do you guys have any doubt from the condensed part, structural formula part? Say yes or no. Shall I go with the bond length structure? Yes or no? Okay. Thank you so much, Sasi, for your response, and for JMV Ramnagar students for your response. Good. Try to interact in the class, okay? You don't have to get scared of me. You can talk very nicely here. Also, bond line structural formula. So, in bond line structural formula, we represent the carbon and hydrogen using a line, right? So, since we have 4 carbon, I have to draw the structure like this. So all the edges denotes the carbon, and each carbon should have 4 bonds. If I take this particular carbon here, it is having only 1 bond, means the remaining 3 are hydrogen. So this has CH3, and here it has 2 hydrogen, and here also 2 hydrogen, and here 3 hydrogen. Okay. So if I write the structure like this is the bond length structural formula for butane. Okay. And for cyclic system, if you want to represent, for example, if I take cyclopentane, pentane means 5 carbon, right? So I have to draw all the 5 carbons like this. This is cyclopentane. So this is the bond length structure for cyclic compound. Okay. So this is how we denote the compound. And this is the representation, structural representation of organic compounds. Then moving on to the next topic, that is classification of organic compound. So organic compounds are classified into 2, right? One is acyclic compound and the other one is cyclic compounds. Acyclic compounds are otherwise called as open chain compounds. Cyclic compounds are called as closed chain compounds. Okay. So what is meant by open chain compounds? So all the methane, ethane, propane, butene, if anything it can be. Okay. All the straight chain compounds and branched chain compounds are called as open chain compounds. Okay. If I want to go for butane, it is an open chain compound. Then coming to the closed chain compound, it is classified again into two. One is homocyclic compound, the other one is heterocyclic compound. What is meant by homo? Homo means same. Okay. So all the atoms which are going to form the cycle, they will be same. For example, cyclopentane. Example can be cyclopentane. Cyclopentane is an example for homocyclic compound. Or it is otherwise called as carbocyclic compound because in most of the cases, not only in most of the cases, in all the cases, if you see, the carbon will be the atom which forms the cycle. So that's why we call the homocyclic compounds as carbocyclic compounds. Okay. And then hetero means, what is meant by hetero? Hetero is different. Hetero means different. So the in forming a ring, one atom will be different. So those compounds are called as heterocyclic compound. For example, we can take, yeah, let me take this as an example. So here I have 4 carbon and 1 oxygen. So one hetero means different. One different atom other than carbon is forming the ring. So those compounds are heterocyclic. So this homocyclic is again classified into two. One is alicyclic compound and the other one is aromatic compound. So this is an example for alicyclic. This is an example for alicyclic, or I can write like this. It is also an example for alicyclic. But when you go for aromatic compounds are having some criteria, right? So we have to follow some 4 rules, and I will discuss those 4 rules at the end of this lesson. So in those 4 rules, the first rule will be the compound should be cyclic and it should be planar. It should have sp2 hybridized carbon, and there should be the delocalization of electrons, and it should follow Huckel rule. So the compound which is following all these 4 rules are called as aromatic compounds. Okay. So don't worry, we will discuss this in detail at the end of this class. And this aromatic compound is classified into benzenoid compound and non-benzenoid compound. So what is meant by benzenoid compound? Benzene ring containing compounds are called as benzenoid compound. So benzene ring containing compounds are called as benzenoid compound. So this is benzene. And if I attach one more ring to this, what is the name of this compound? Can you guess the name of this compound? If 2 benzene rings are fused together, what is the name of this compound? It's very easy, right? What is the name? What is the name? Do you guys remember the name of this compound? It is naphthalene. Very good, Naresh. It is naphthalene. Good. It is naphthalene. Now coming to non-benzenoid. So benzene ring will have 6 carbon in it. So some other compound, for example, what compound we will take? We will take a tropolone, okay? So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, and here let me put double bond. So here I have a 7 carbon containing ring with 1 double bond oxygen. Okay. Here if you see, this particular ring is having alternative double bond which undergoes delocalization. So it is cyclic, it is planar, and all the atoms are sp2 hybridized, and it is following Huckel rule also. But instead of 6 carbon, it is having 7 carbon. So the rings or the aromatic compounds which doesn't have 6 carbon but follows all the rules of aromaticity are called as non-benzenoid compounds. Okay, the name of this compound is tropolone. Name of this compound is tropolone. Okay. So this is how we classified all the organic compounds, and some more examples also we might have discussed in the class. You can go through that also. Now I am giving you the gist of it. Okay. So shall I move on to the next topic? So we have seen the introductory part of organic compound. Okay. And then the structural representation we have seen. And now I have covered the classification of organic compound. Shall I go with the next topic? Do you have any doubt from the 3 topics that we have discussed so far? Shall we move to the next line? The next topic is functional group. Any doubt? Shall we go with the next topic? Say yes or no. Yes. Okay, Naresh. We'll go. We'll go with the functional group. So what is a functional group? An atom or group of atoms joined in a specific manner which is responsible for the characteristic chemical properties of an organic compound. Simply to say, the reactive part of the molecule is called as functional group. Okay, for example, here is an example. So here I have OH. The OH is called as hydroxyl group and that is the functional group of this compound. Okay, in place of in OH part only, the chemical reaction will occur. So the reactive part of the entire molecule is called as a functional group. Then coming to the next example, it is CHO. Okay, CHO is called as aldehyde. Okay, that is a functional group. And here we have COOH. Carboxylic acid is the functional group of this molecule. Okay, so this is about the functional group and we have a list of functional group also. You might have written those things in your class notes. Okay, so we have nearly 13 to 15 important functional group list. Okay, so go through those lists. The name, group, structural formula, prefix and suffix. So these things are very important. Okay, so that will be very helpful in while solving the nomenclature part. Okay, this is the functional group. And coming to homologous series, so it is a group or a series of organic compounds, each containing a characteristic functional group, forms a homologous series. Homo means same. Okay, suppose if I have to write the homologous series of alcohol, so the first member of alcohol is CH3OH. And if I add one more CH2 to this compound, I will get the second member. If I still add one more CH2 to the second alcohol, I will get the third alcohol. And by adding one more CH2, I'm getting the fourth alcohol. So the addition of CH2 unit, to each member is leading to a class of compounds called homologous series. It is a group of organic compound, or we can say it is a class of organic compound. Suppose if I have to write the homologous series of alkanes, who is the first member of alkane? Can you give me the formula for the first member of alkane? Who is that? Okay, I'll give the first member. You give me the second member. Okay. So the first member is CH4. Very good, Yoga. Who is the second member? Just add CH2. Just add CH2 to CH4. What you will get? You will have 2 carbon and 6 hydrogen, right? So it is C2H6. I can write C2H6 as CH3. Yeah, very good, Suma. It is CH3. Very good, super. Now, if I add one more CH2 to this, what I will get? CH3, CH2, CH3. Very good, Divyanush. It is C3H8. So you guys are so enthusiastic. Very happy to see you guys like this. So keep this spirit till the end, okay? So if you add one more CH2 to this, you'll have the fourth compound. Now, this particular thing is forming a class of compound. So the members of the series are called as homologous. Okay, and those class of compound is called as alkenes. Okay, by the repetition of CH2 unit, a class of compound is forming, and we are calling those class of compound as a series, and those series are called as homologous series. Okay, so with this we are closing this homologous series. Then the next topic is the trivial name of organic compound. The trivial name of organic compound. What is meant by trivial name? Trivial name is called as common name. Trivial name is called as common name. So we have some common names of some organic compounds. So here is the list in front of you. We are having this list in our book also. And during the class time also you might have noted it down. So CH4 is called as methane. And 4 carbon containing alkane is N-butane, isobutane, neopentane, CHO containing compound formaldehyde. CO means it is ketone, so it is called as acetone. CHCl3 is chloroform. COH containing compound with 2 carbons, so it is acetic acid. Acetic acid is present in vinegar, right? So that is acetic acid, and C6H6 is benzene, OCH3 with C6H5 anisole, aniline, acetophenone, ethyl methyl ether. Okay, so all these are the common name of the compound. So common name can be understood by all. Okay, if many can understand the common name, many will use the common name. Then coming to the IUPAC name of organic compound. So what is the full form of IUPAC? It is International Union of Pure and Applied Chemistry. Right, International Union of Pure and Applied Chemistry. So this particular institution, they have come up with some rules. Okay, they have come up with some rules to name an organic compound. So before moving on to the rule, let me go with this skeletal structure of IUPAC system. So in the skeletal structure, first we will have a secondary prefix, then we will have a primary prefix, then comes root word, then comes primary suffix, and at last we have a secondary suffix. So this is the skeletal structure of an IUPAC nomenclature. Okay, so what is a root word? Root word denotes the number of carbon atoms in the parent chain. Who is the parent chain? The longest carbon contained, the more number of carbon containing chain is called as parent chain. So the number of carbon atoms in the parent chain denotes the root word. Okay. So primary suffix, coming to primary suffix, so it denotes the unsaturation. Alkane means it is a saturated compound. Alkene and alkyne are unsaturated compound. Alkene means we will have double bond. Alkyne we have triple bond. And coming to the secondary suffix gives the main functional group. Suppose in our compound, if we have OH, we have to end the name with OL, alcohol, right? Suppose if we have COOH, then we have to end the name with carboxylic acid, that is oic acid. So that secondary suffix denotes the main functional group or the functional group with the first preference. Got it? Then coming to the primary prefix, so the cyclic compounds, all the cyclic system will go as primary prefix. Like in case of cyclopentane, we are writing no. So in front of pentane, I am giving cyclo. So it is called a cyclopentane. Cyclopent is the root word. Pent is the root word. Cyclo is the primary prefix. So for all cyclic compounds, we will use primary prefix. And then the secondary prefix denotes the substituents with locants. Suppose if we have two or more than two substituents in our compound, then we will start numbering the compound, numbering the parent chain, right? So while numbering, we can give 1, 2, 3, 4, 5, 6. So for example, in case of third compound, third carbon, if I have CH3 group, then I will name that as 3-methyl, 6-ethyl. So I will go like that, no? So those numbers and the substituents will be represented as a secondary prefix. Got it? So this is the skeletal structure of an IUPAC nomenclature. Okay. So shall I go with the one by one? Shall I go with the root word? Is this clear to all of you? Shall we go with start? Just give me a moment. Just sorry, Sasi. Locant. Yeah, I will tell you what is a locant. Okay. Locant means while discussing the rules of IUPAC nomenclature, I will tell you what is a locant. Is it okay? Okay, fine, good. So I'll go with the root word. So if I have only one carbon in my compound, then the root word that I have to give is meth. If I have 2 carbon, eth. 3 means pro. 4 but, 5 pent, 6 hex. If you have 7 carbon, it is hept. Okay. If I have 8, then it is called as oct. If I have 9, then it is non. If I have 10 carbon, then it is called as dic. Okay. So these are the very important and common root word we will be using throughout our organic chemistry in the nomenclature part. Okay. So these are the root words. Then coming to the UPAC nomenclature of hydrocarbon for straight chain hydrocarbon. Straight chain means there won't be any branches. Okay, only a single chain. So the names of such compounds are based on their chain structure. Suppose if I am having an alkane, alkanes are the compounds which has only carbon-carbon single bond. The name ends with the suffix ane for them. Okay, now I'll give you a list. You see here, if I have only one carbon containing alkane, it is called as methane, ethane. 3 means propane, butane. So here, meth, eth, prop, but. So these are the root word. And this ane denotes the suffix. Ane denotes the suffix pentane, hexane, heptane, octane, nonane, decane, icosane. It is triacontane. It is actually triacontane. Okay, it is triacontane. With carbon 30 carbon is triacontane. So these are the nomenclature for the straight chain hydrocarbon. Now next, coming to the nomenclature of branched chain alkanes. So for branched chain alkanes, we have to follow a set of rules. Okay, rule number 1 is, first of all, you need to find out the longest carbon containing chain in the molecule. Okay, longest carbon chain in the molecule is identified first. So I'll give you a compound. So this is the compound. So the longest, more number of carbon containing chain is the straight chain. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 and 9. Very good. Very good, Naresh. So the longest carbon chain is 9 carbon containing the straight chain. Now, next, rule number 2 is you have to number. Okay, the numbering is done in such a way that the branched carbon atom should get the lowest possible number. The branched carbon atom should get the lowest possible number, and this is called as locant rule. This is called as locant rule. Okay, the lowest possible, the number is called as locant. Okay, so here you see, here in addition to this straight chain, we have 2 substituents, 2 branches, right? So in this first branch, we have only 1 carbon and it is called as methyl. In the second branch, we have 2 carbon, so it is called as ethyl. Okay, so there are 2 ways of numbering. One is from left to right. So here, left to right numbering is done. The other way is right to left. In right to left, how I will number? I will number like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So in left to right numbering, if I add the carbon atom numbers to which the substituents are attached. So for left to right numbering, methyl is attached to the second carbon, ethyl is attached to the sixth carbon. So 2 plus 6 is equal to 8. Okay. For right to left numbering, the substituent is attached to the fourth carbon. Ethyl is attached to fourth carbon and methyl is attached to eighth carbon. So 4 plus 8 is 12. Okay. Now, which is the correct way of numbering? The numbering is done in such a way that the branched carbon atoms should get the lowest possible number. Lowest possible number is comparing 8 and 12, which is the lowest number? 8 is the lowest number. So that is the correct way of, left to right is the correct way of numbering for this particular compound. And right to left way of numbering is incorrect. Okay. So this is called as locant rule. This is okay. Yeah. Good. Naresh, good. So one of you have asked me the doubt, right? Like what is locum? Who is that? Who is that? Sasi. Sasi, is this okay now? Is this clear? Do you have any doubt from this? Yes. Now the 2 for 2 and 6. So it is called as 6-ethyl 2-methyl nonene. It is called as 6-ethyl 2-methyl nonene. So the third rule, names of alkyl groups attached as a branch are then prefixed to the name of the parent alkane, and position of substituent is indicated by an appropriate number. So methyl and ethyl are the substituents. Okay. So since we have two substituents, we have to go with the one according to the alphabetical listing. We cannot go like 2-methyl 6-ethyl. We have to go with 6-ethyl and 2-methyl because E comes first in the alphabet. Then only M comes. So while naming the organic compound, start from the substituent that is coming first in the alphabetical order. Okay. So the position of the substituent. So ethyl is attached to 6th carbon, methyl is attached to 2nd carbon. So 2 and 6 are the position of the substituents. Okay. And those two substituents, ethyl and methyl, they should go as a prefix to the parent alkane. They should go as a name to the prefix to the parent alkane. So parent root word is non. Root word is non, and ane is the suffix. 6-ethyl 2-methyl is the prefix. Okay, so these substituents has to go as a prefix to the name of the parent alkane. Okay, then coming to, yeah, there should not be any gap here. There should not be any gap. Okay, everything prefix, root word and suffix, everything should be a single name. You should not leave any gaps in between the root word or a suffix or between prefix and root word. Okay, there should not be any break or gap. If different alkyl groups are present, they are listed in the alphabetical order. This is what we have done for this compound. Okay, so this is rule number 3. So first find out the longest carbon chain, then start numbering. If you have substituent, start from the substituent. If you have more than one substituent, go with the alphabetical order. Okay. Then coming to the 4th rule. If 2 or more identical substituent groups are present, then numbers are separated by commas. Like for example, if I have 2-methyl or if I have 3-methyl, if I have 2-ethyl in my compound, I'll show you the compounds. Okay. So the name of such identical substituents, they are not repeated. Instead, prefixes such as. So if I have 2-methyl, then I have to use dimethyl. If I have 3, trimethyl. 4, tetramethyl. 5, pentamethyl. 6, hexamethyl. So I have to go like this. Okay. So I'll give you an example. So here, see this compound. This compound is having 5 carbon in its parent chain and 2 substituents. Both the substituents are methyl. So what I have to do? I have to write like 2, 4 dimethyl. It is 2, 4 dimethyl. Each time I should not write methyl, 2-methyl, 4-methyl pentane. No, that is not the correct way of naming. So 2, 4 dimethyl pentane is the correct way of naming this compound. Okay. Now I will give you one more compound. Actually, there should not be any H here. Okay, so this is the compound. Can anyone give me the name of this compound? Can anyone try the name of this compound? What is the name of this? How many substituents we have here? 1, 2, 3, right? What is the name of this compound? Two, 4 trimethyl pentane. Very good, Naresh. You are correct. But that is only there's one small mistake. Yeah, good, Suma. 4 trimethyl pentane. You're also doing it. Naresh have left space in your name. Okay, so just correct it. So that is the only small mistake you have done. So otherwise your name is correct. Okay, good, good. 2,2,4 trimethyl pentane. Very good. What about this? What is the name of this compound? What is the name of this compound? So how many substituents we have here? So CH2, CH3. This is ethyl, and here I have one methyl, and here I have another methyl. What is the name of this compound? What is the name of this compound? So we have two different types of substituent. One is ethyl and the other one is methyl. So if two different substituents are there in your compound, then you have to go with the alphabetical order, right? So E comes first in the alphabet. So what could be the correct IUPAC name? 3-ethyl 4,4 dimethyl heptane. Very good, Stephen. Very good, Cecil. Good. 3-ethyl 4,4 dimethyl heptane. Good. You have understood all the four. Good, good. All of you are doing great. Good students. Good. Then coming to the fifth rule. If two substituents are found in equivalent position, the lower number is given to the one coming first in the alphabetical listing. Suppose you take this as an example. Okay. So here I have two substituents. Here I have two substituents. One is ethyl and the other one is methyl. So if I go for left to right numbering, for left to right, 3 and 6 I am getting. 3 plus 6, which is equal to 9. If I go for right to left numbering, right to left means 1, 2, 3, 4, 5, 6, 7, 8, right? Methyl is taking 3 and ethyl is taking 6. So again 3 plus 6, we are getting 9. So two substituents are found in equivalent position. So now what I have to do? The lower number should be given to the one which is coming first. Very good. Very good statement. Coming first in the alphabetical list. So E comes first in the alphabet. So that should get the lowest number. So it is named as 3-ethyl 6-methyl octane. It is 3-ethyl 6-methyl octane. Very good. So these are the 5 important rules you have to keep in your mind while naming the branched chain alkanes. Okay. So now I will go for the nomenclature of cyclic compounds. So the saturated monocyclic compound is named by prefixing cyclo to the corresponding straight chain alkane. Okay. Now, if I have 5 carbon, it is called a cyclopentane. Okay. Here in the cyclic compound, in the cycle, I have 6 carbon, but I have 2 substituents. So who are those two substituents? Here I have 1 carbon. 1 means it is methyl. And here in the substituents, how many carbon I have? 1, 2, 3. 3 carbon I have. So this is propyl. Now what I have to do? I have to start numbering, right? So that numbering should be done in such a way, like it should be done in such a way that the one which is coming first in the alphabetical listing should get the first preference. So alphabetical order of numbering should be given. So here you see, if I go in a clockwise manner, I am putting like this 1, 2, 3. So the first substituent is getting number 1 and the second substituent is getting number 3. So for clockwise, 1 methyl, 3 propyl, cyclohexane. Very good. So for clockwise numbering, I am getting 1 plus 3. If I go with anti-clockwise, for anti-clockwise, what I will get? 1, 2, 3. So again, I am getting 1 plus 3 only for substituent attached to carbon. Okay. So in this case, we have to go with the alphabetical order. So your name is correct. 1 methyl. So M comes first in the alphabet. Then only T comes. So it is 1 methyl, 3 propyl cyclohexane. Very good. So I'll give you one more compound. Try to name that compound also. What is the name of this compound? Can anyone try the name? How many substituents we have? 3 substituents we have. Try to number and give me the correct IUPAC name of this compound. I will give you few seconds. You guys can give a try. 1-ethyl 3,3 dimethyl cyclohexane. Naresh and Stephen, your name is 80% correct, but there is one small mistake you both have done. Can you find that mistake and rectify that mistake and give me the 100% correct answer in the chat box? Has anyone found out? Did you get? What about the others? Others try to find the mistake that those two guys have done. Stephen and Naresh, lowest sum. Yeah, that low control. Now, yeah, 3-ethyl yoga. Yoga, your answer is correct. Yoga is correct. 3-ethyl 1,1 dimethyl cyclohexane. Why? So since we have three substituents, both these two are methyl and this particular third is ethyl. Now, if I go in a clockwise manner, I will give 1, 2, and 3, right? So, since the first carbon has two substituents, it is 1 plus 1 plus 3. So, the answer is 5. If I go in an anti-clockwise manner, like 1, 2, and 3, so what I'm getting? 1, 1 for ethyl, 3 for methyl, and the other 3 for the second methyl. So, the final answer is 7. Now, I have to follow the lowest low control, right? So, I have to number in such a way that the substituent attached carbon should get the lowest possible number. So, the clockwise way of numbering is correct. So, here, but while naming the compound, you have to go with the alphabetical order only. For naming, you have to go with alphabetical order only. So, in alphabetical listing, E comes first. So, it is 3-ethyl 1,1 dimethyl cyclohexane. Okay, clear for all? Any doubt from this? So, any doubt from the low control or for naming the compound? Shall I go for the? Yeah, good. So, we will move on for the nomenclature of compounds with one functional group. Okay, so let's go. So, for the compounds which has functional group, for those things, step number 1 that you have to follow is you need to identify the functional group first. So, I'll give you a compound. Can you identify the functional group? Who is the functional group here? OH is the functional group. Very good. OH is the functional group. So, it is named as alcohol. So, what is the suffix for alcohol? What is the suffix we use for alcohol? No, hydroxy is the prefix. Stephen, hydroxy is the prefix and OL is the suffix. Very good, Sasi. OL is the suffix. Now, for the first step is we need to find out identify the functional group. The second thing is you need to number the longest chain, and as usual we do for the other things for branched chain hydrocarbon. The same thing we have to do here also. We have to give the first preference, that is the lowest number to the carbon possessing the functional group. So OH attached carbon should give the lowest number, and accordingly we have to number. So here right to left numbering is giving the lowest number for the carbon to which the OH is attached. So lowest possible number is 2. So that is correct way of number. Then the third step is assign a root word. So in this compound we have 5 carbon. So the root word is pent. Okay. Naresh, your answer is 80% correct again. Okay, so let's see the 20% mistake in your answer. So it is in yoga's answer also a very minute mistake is there. Yoga has left a thing. So it is pent, root word is pent. And step 4 is you have to assign a primary. Yeah, Stephen answer is correct. But the most appropriate answer is not given by Stephen. Stephen answer is also correct. More appropriate. Yes, JNV Ramnagar students, you want to say something? You have raised your hand, it seems. pentan to all. Very good. Pentan to all is the more appropriate correct answer. Most correct. Okay. Good. Jain with Ramnagas. Others are also giving a try. Good. Really great. So here we have to assign a primary suffix. So suffix for alcohol is, yeah, primary suffix is alkane. Since the compound contains single bond, carbon-carbon single bond, primary suffix is alkane. Secondary suffix is OL. Okay, secondary suffix is OL and functional group position is 2. So so what I have to do? So in primary suffix, I have to remove the E and I have to replace that E with the secondary suffix, that is OL. So the IUPAC name will be pentan to all. So here pent is the root word, AN is the primary suffix and OL is the secondary suffix. Okay. So this compound doesn't have primary prefix and secondary prefix because we don't have any alkyl groups or the other things attached. We have only the functional group. Got it? So the main functional group has to go as a secondary suffix, right? So we are putting it according. 2-pentanol is also the correct answer. 2-pentanol is also correct, but the position that the number 2 should be given or should be written before the functional group. Okay, before the functional group suffix. So that is the more appropriate answer for a compound. Okay, all of you have done a great job. So next, we will go for the nomenclature of compounds with more than one functional group. So here is one compound and this compound contains 2 functional groups. Can you identify those 2 functional groups and tell me the name of those 2 functional groups? Who are the 2 functional groups present here in this compound? Very good. Ketone and carboxylic. Yeah, ketone and carboxylic acid. Carboxylic acid is the main functional group. Okay, it is coming first in the priority order. So I will give you the priority list also. So here is the class of organic compound arranged in a priority in preference. Okay, a carboxylic acid is coming in the first position, then sulfonic acid, ester, acyl halide, amide, nitrile, aldehyde, ketone, alcohol, amine, alkene, and alkyne. Okay, so you have to study all the functional groups in this order. Okay, so that you will not get confused if 2 or more than 2 functional group containing compound is given to you in the question. Okay, so this first preference is given to CO voltage. So here if you see, we have 2 compounds, I mean functional group, one is ketone and carboxylic acid. Carboxylic is getting the first preference, that is number 1, and ketone is getting number 5. Okay, 5-oxo hex 1-oic acid. Okay, we will check. So if the functional group is getting the second preference, then we have to go with the prefix. We have to go with the prefix. The prefix suffix tabular column I have already given you in the class. Okay, we have to use the prefix. So the prefix for ketone is oxo. Prefix for ketone is oxo. So now ketone is acting as a substituent. Since it is going with the second priority, it is a substituent. So it is 5-oxo, and the longest chain is having 6 carbon with the carbon-carbon single bond. So it is 5-oxo hexane. Very good. And the main functional group is carboxylic acid. It is in the first position. So it is hexane oic acid or hexane 1-oic acid. Both are correct. Okay. For number 1, you can write that 1 or you cannot write. That is not the problem. For other numbers other than 1, you have to mention the number. Okay. So here it is called as 5-oxohexanoic acid or 5-oxohexane 1-oic acid. Both are correct. Both are correct. So this is how we have to number. Then coming to the nomenclature of aromatic compounds. Nomenclature of aromatic compounds, mostly we will have the benzene containing compounds. Right? Substituent is placed as prefix to the word benzene. If I have CH3 attached to benzene, it is methyl benzene. OCH3 means methoxybenzene. NH2 is aminobenzene, CHO benzaldehyde, NO2 is nitrobenzene, bromobenzene, benzoic acid, and phenol. Okay, so all these are the mono-substituted benzene compounds. And all these are very important and easy also. Most common compounds we will be dealing in the whole entire organic chemistry of both class level and okay. So you should know all these things. Then coming to the nomenclature of disubstituted benzene. So here I have two substituents, 1 and 3. So two substituents are in the meta position. Okay. So the lowest number you will get when you start from one of the substituents, 1,3 dibromobenzene. Very good. So that is the lowest number. It is 1,3 dibromobenzene. If two substituents are in the opposite position, then it is para. If two substituents are in the adjacent position, then we call those as meta. Adjacent means, ortho. Adjacent means ortho. That is, if they are in the 1,2 position, it is ortho. If they are in 1,3 position, it is meta. And if they are in 1,4 position, it is called as para. Okay. Now this is in meta position. So in IUPAC name, we should not use ortho, para, meta and all. We have to number. We have to give the number. So it is 1,3 dibromobenzene. Okay. This is the disubstituted compounds. And we have trisubstituted compounds also. And after this, with this, the nomenclature part of the things are all getting over. The next topic is isomerism. This isomerism we will discuss in the next session. Tomorrow we will discuss the isomerism part. Okay. So we have covered introduction till nomenclature of GOC lesson. Do you guys have any doubt from the parts that we have discussed so far into today's session? Is everything clear and okay? Fine for you? Am I going very fast? The speed is okay, right? If you want me to go slow, just let me know. If you want to go me very fast also, just let me know. Okay. Sasi, you want me to go very slow? I'm saying yes, ma'am. Yes, ma'am. Is for which question? Should I? No, ma'am. Okay. So tomorrow we will, clear. Good. So fine. Thank you all. Thank you so much for listening to today's lecture. See you all in the next session with isomerism. And after completing this lesson, we will solve some questions related to this. Okay, some JE and NEET questions we will discuss. Okay. So thank you so much, students. Thank you. Take care. Bye-bye. Bye-bye. Thank you. Thank you. Thank you.